Good morning and afternoon, everyone. Welcome to today's webinar, Data Innovation Trends for Financial Services. My name is Alicia and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. You can also follow us on Twitter at MemSQL or live tweet us during the webinar using hashtag MemSQLwebinar. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. Let's begin today's presentation on data innovation trends for financial services. Financial services companies are on the forefront of applying data to create a competitive advantage. New applications and analytical systems are putting increasing pressure on data infrastructure, forcing new approaches to data ingestion, processing, and response. In today's webinar, we'll discuss how financial services leaders are making real-time and predictive decisions to improve the customer experience, business operations, and manage risk. With that said, I'd like to introduce our speaker, Mike Boyarsky. Mike is Senior Director of Product Marketing at MemSQL. Mike has extensive experience in databases and analytic technologies, having worked at some of the leading database and BI tools in their space. Thank you for joining us today, and welcome, Mike. You have the floor.
Excellent. Thank you, Alicia. And I want to thank everybody for attending today. We've got a pretty full agenda. And so maybe go to the next slide here and making sure that people are seeing the slides. Great, awesome. So we're going to talk about some of the new, essentially data trends and initiatives that are happening within the banking community. At MemSQL, we've been lucky to be part of many large Fortune 500 level banks. We actually are helping power the 5 of the top 10 the banks in North America. And so part of this is going to be sharing some of those experiences through case studies and reference architectures and examples. We will spend some time going over MemSQL just for folks that are new to our technology and our product. So I want to make sure folks they have a basic understanding of our platform, and then we'll get into the details of modernizing data, accelerating data for the purposes of financial service applications. And so it's always important to set some context around why banks are always at the forefront of managing data, innovating with the digital transformations that have been going on for a number of years. It's still a top priority, according to Gartner's latest report, the CIO Agenda report. Digital transformation, clear leader in terms of investment priority and attention for CIOs. And Gartner is looking at this from a perspective that moving to digital drives revenue. It helps new operating models, and it can deliver new digital products and services. So that's sort of the thrust behind sort of the digital transformation initiatives. And then in terms of sort of the macro data trends that are happening within banks, they are sort of under these categories. They are around the premium experience and designing and developing better experiences for customers, whether that's the high net worth clients, whether it's more automated advisory, personalization. All of these are sort of helping improve the engagement with customers. There are, as many banks are facing right now, new categories of customers. Some of them are digital natives, and they want those experiences to be personalized and always on. We also see a lot of AI and ML infused services happening, so improving detection rates for fraud, getting into more, again, sort of automation of advisory services using ML functionality. And then even in the portfolio analysis space, we're starting to see a lot of ML techniques being used to automate risk and other performance and optimization tactics for maximizing portfolio returns. If we go to the left, we see cloud. Has been a trend for many industries. In some cases, financial services might be laggards in terms of adopting cloud, but we are starting to see some shifts happening. A lot has to do with the fact that you can adopt ready-made or built AI and ML services. Many of those are already pre-built, and sort of already designed for scale. We see a lot of elastic compute advantages. So the fact that you can essentially ready turn on a compute infrastructure for on-the-fly demand that's unexpected. And then the hybrid architectures that are part of the cloud, we do recognize that there's still a lot of data that's on-prem, and so there's spot services that are happening in the cloud. And so to be able to intelligently span those two dimensions between on-prem and cloud and do that smartly is certainly part of that growth trajectory in the cloud. And then in terms of risk management, there's no doubt the goal for most banks is to mitigate against risk and be very efficient in that process. In many cases, it's the cost of doing compliance reporting and making that more automated. We see a fair amount of customers trying to innovate around doing more real-time trade analysis and portfolio rebalancing analysis ahead of decisions so that you can understand the impact of a potential trade and or rebalance function. And then with the advent of a lot of ultimately HDFS and Hadoop infrastructure, the role of big data governance is becoming something that's important, something that can be costly, and so optimizing risk for the purposes of governance is becoming also an investment area. So when we see the real data innovations from the data infrastructure perspective, a lot of these are trends that, again, from a MemSQL lens, we're seeing repeat interest as well as investment. So the first is eliminating event to insight latency. So the moment a transaction, whether it's in a market event, whether it's a trade, to be able to ultimately analyze that event, folks are trying to shorten that time span, and it has a lot to do with the gradual reduction of batch processing that's occurring. A lot of that's driven by an enormous influx of Kafka-based technologies that are replacing some of the legacy ETL tools and processes. We are also seeing banks looking to invest in block-free architectures. So there's a lot of traditional database technologies that were really designed to protect against and ensure the accuracy of data. And so that provided a lot of locking architectures. So there's a lot of waiting that occurs for some of these systems that are trying to move to more real time. And then we also are seeing a lot of demand for just getting the best latency possible really has to be driven by, in some cases, in-memory technologies. And in-memory is important, but it also needs to be done smartly because certainly costs can be a factor for how far you want to go with your in-memory compute strategies. We also see, just from a general agility of your architecture, when you're moving to more of a real-time system, you need better agility, and that has a lot to do with moving to more modernized distributed or scale-out compute. Scale-out provides a bunch of advantages, largely around simplification and the speed in which you can add nodes to deliver the necessary resources for your application. We see a lot of need or demand around tiered storage for your data processing and data management. That means the ability to flexibly select and identify the role of in-memory versus disk or SSD, and to be able to essentially determine where in your application you want to select the investment of that particular storage architecture to maximize your response time. Parallel processing is also something we see a lot of applications running into scale problems. Scale can be addressed with the combination of a distributed architecture with parallel processing. So the ability for more things to run at the same time, whether that's at the ingest rate, whether that's at the query level. And so the ability to do more parallel processing at scale delivers ultimately the best performance. And then all of this needs to be able to work with and fit in with existing infrastructures and skills. So we continue to see an interest and demand for standard SQL. I think a lot of data technologies over the last few years believe that you can't get scale and you can't get performance if you're going to rely on the relational SQL model. And so the challenge with that is that you have the interoperability problems between a non-standard SQL interface and the tools and breakage that might occur for your other technologies, as well as just the skill set. The fact that in some cases the SQL standard is pretty well recognized, and if you're having to learn a new SQL variant, you may impact the availability of that data for the organization in terms of usability. Highly available architectures are really becoming they're expected, but doing this with a shared nothing architecture really is kind of determined to be the best approach. And so the architectures that are able to mitigate against multi-node failures and still run effectively is really ultimately what the best data processing platform that you can go with. And then security becoming increasingly more and more important. There continues to be breaches and unexpected events, whether those are fraudulent in nature, whether those are hacks. And so comprehensive security across the spectrum of authentication, encryption, logging, etc., and all of that security frameworks working with already heavy investment of technologies already in place, whether it's Kerberos or GSS APIs or the PAM interface. All of these are important because we don't want to necessarily bring a new technology and then new security architectures. So in terms of the modernization requirements within banks, we see a number of categories or trends happening. If you're going to deliver scale and performance for the applications that I pointed out earlier, whether those are personalized applications, whether those are delivering a premium service, whether you're looking to automate advisory, all of these require scale and performance. And so how do you get there from your existing infrastructure? Largely requires a combination of factors, whether it's augmenting a single node database architecture, whether Oracle, Sybase, or Netezza. Many of these are designed for specific types of scale out or scale up data processing, and there are a number of limits that occur within these architectures. Some of them are expensive limits. In other cases, they are physical limits. We also see Hadoop becoming the standard for the quote cold storage or archiving of data. And how do you get query optimization and performance for those archived data sources without necessarily having to move that data to some other environment? So Hadoop acceleration through augmentation with a SQL interface is also an investment area that we're seeing a lot in. Getting down to more continuous ML and AI applications, so the ability to constantly model and monitor and improve those models of your applications with new data or fresh data is something that we're also seeing. And then lastly, as I pointed out earlier, a path to the cloud that's not disruptive. So the ability to move to the cloud, whether building on-prem and then moving that architecture to the cloud, or building natively on a cloud service, a lot of organizations want options and choices on that movement or flexibility. So before I get into some of the example applications, I want to spend just a few minutes on who MemSQL is and what we offer, just for those that are new to the technology. Our mission here at MemSQL is to deliver speed and scale for your critical data infrastructure. We are a top-ranked database and data warehouse, so that's something that a lot of folks may not realize, that we actually have two essentially engines in one, and so that's what allows us to deliver the great performance. We have a number of customers across industries. We do tend to find ourselves in the data-driven organizations. That's probably one of the reasons why many of the banks are working with us. I wish I could show their logos, but we don't have their approval to do so. But you can imagine that at the scale of the Comcast, Sony, Cisco, Samsung, et cetera, that we have similar sort of scale and sized banking organizations that are part of our portfolio as well. We call ourselves the No Limits database because we are a scale-out relational SQL database. That means we have physically no limits in terms of how much scale you can deliver from the platform. That gives you great performance both at the ingest as well as at the query performance level. So as I mentioned earlier, we are a database and a data warehouse. And so when you think about database performance, that's a transactional workload. So that's a update or an upsert, and that's really important for stream ingestion. But then also at the same time, we provide a query interface. So we have a data warehouse that can give you extremely low latent queries, and I'll talk a little bit about how we achieve that. And then because we're scale out, we have the ability to support a high number of concurrent users. And so it's really the best of all worlds in that you have a platform that can deliver a multitude of workloads with a scalable compute processing system that leverages both a cost-effective commodity hardware architecture that spans memory and disk. We can be deployed anywhere, so we do not require any particular cloud or on-prem infrastructure other than that it runs on Linux, and so that's our only dependency. And we are routinely able to deliver dramatically better performance at a much more cost-effective level than the legacy database providers. We work with a number of technologies. As a database, you have to be able to connect to a number of data sources, whether those are real-time in nature, like Kafka, or a change data capture routine like Attunity, whether you're using full-blown ETL tools for transformation, or Spark for your ML workloads or other live transformational events. We can ingest data from other operational databases or data warehouses, and we see a fair amount of customers also using our built-in HDFS or S3 connectors to ingest data directly from those object stores or archive sources. And then when it comes to getting data out of the system and doing analytics, we work with a number of BI tools off the shelf. So we have native connectors to Tableau and Looker and MicroStrategy. And so those are a number of ways to connect. We're just like a relational SQL database that, like a Postgres or an Oracle. It's the differences that we scale, we provide great performance, but we look and behave just like any of those traditional systems. I'll quickly walk through MemSQL at a glance and leave this up here for a few minutes just to highlight the fact that we are full ACID compliant. We are an ANSI SQL database, so we believe in relational as the proper structure to both ingesting data as well as getting data out. We support a bunch of data types, whether it's JSON or geospatial based. Avro has also become a new data type that we've added to our system. We are full in memory and solid states. That means we span both memory and disk. That allows us to give our customers a lot of flexibility and choice between where they want their performance gains. I'll talk a little bit about our row store and column store in a moment. We are full distributed, so that means shared nothing. It's fully massively parallel processing, and everything runs on commodity hardware, so we don't require any specialized hardware configurations. We can run off the shelf on any EC2 environment, etc. And so as I pointed out earlier, we are flexible in our deployment, so we have customers running on just about every cloud out there, as well as on premises. We have about, I think, 40 to 50% of our customers are running us on some public cloud infrastructure. So the value of MemSQL comes in our architecture, and this is sort of under the hood one of the main advantages, and it's the fact that we can very quickly ingest data and pipe that into an in-memory row store and or a memory and disk oriented column store. So this is where the unique advantage of MemSQL lies, is the ability to ingest directly into in-memory row store for high throughput transactions, but also you can do quick lookups and get that millisecond, tens of millisecond response time using our in-memory engine. However, if the data sets are large and significant and or you are looking for more of a traditional data warehousing architecture, you can put and stream data directly into our column store. Some customers stream into both. Some start and stream directly into memory, and then they move some of that data over to disk when appropriate. It's the choices and the flexibility for how you want to process your data is what sets MemSQL apart. A lot of our competitors will give you one choice only. So you have to ingest everything in memory first, and or you have to ingest everything onto disk first. We give you the choice. And when it comes to row-oriented tables and column-oriented tables, it really is about the type of application that you're building. Row-oriented tables are great for that transactional system. Those OLTP-based environments can give you very fine-grained aggregations, and there are of course no compression because of the row-oriented format, but you get very fast gigabytes to terabytes of data, updates, deletes, etc. In the millisecond time frame. In our analytical column store environment, it's really meant for big data environments. So we're talking terabytes to petabytes of data. So you get the great compression. We have the aggregation framework, of course, that you would expect. And so this is where we act like a data warehouse. And so it's the combination of a data warehouse with a database that is what gives us our ability to deliver real-time analytics across a spectrum of data. So now we'll spend some time on our use cases. And so the first will be a case study around wealth management. And this is ultimately about that customer experience. In this case, this bank was looking to deliver the premium best possible experience for their highest net worth clients. And that included delivering millisecond response across every single interaction that's possible within their dashboarding environment. Their architecture started with a pretty traditional format, which was pulling data from a variety of sources, largely using ETL, doing their processes in batch into their data warehouse, and then over time they would archive some of that to their Hadoop cluster. And what they were finding was that their batch loading process was not as efficient as possible. So they had to create a number of data marts, essentially. So their data warehouse architecture became split into many. So they started to find that they had to essentially create multiple pipelines and segment their data sets into multiple data marts to get to the proper loading windows that they were looking for. So batch processing as the foundation of their architecture was a problem. It also prevented them from doing a lot of real-time queries of the data as loads were happening with the data warehouse. They had to essentially prevent some of the live data from being accessed in the system. They also couldn't load they couldn't provide access to all of the history for their customers, so they were offloading multiple years onto their HDFS environment, and that was not accessible directly from the dashboarding environment, and so that provided a limited view for their customers. And so what they wanted to do was get to a more comprehensive view using a faster data store. And then lastly, the query response of the dashboards were inconsistent. So in some cases they were seeing tens to hundreds of milliseconds to seconds of query response, and that was not the experience they wanted to deliver to their clients. They wanted lightning fast at a blink query response every time. And so even under the market conditions where corrections in the market resulted in a big influx of query concurrency, they still wanted to deliver that premium response. So they moved to a new architecture, adopting Kafka as their primary ingest and integration technology, and then piping that directly into MemSQL. And then on occasion, MemSQL would then archive some of that data using a Spark process into HDFS. And what they got with this experience was, first of all, they got to a streaming architecture. So they were able to enable Kafka as their primary data feed into MemSQL. Kafka and MemSQL work perfectly together because they both provide sort of that lock-free streaming data movement architecture. So MemSQL does not put locks on it uses a skip list index which does not essentially create locks on your data. And then ultimately, we also have a built-in pipeline functionality that works with Kafka out of the box. And so this really put the two together for a really elegant solution. They were also able to provide query response across a larger data set. And so they were able to get to more years of data so they could give their clients history and a more comprehensive view of their portfolios. And they got to the millisecond response demand that their SLA required. So at this point, they were at the 40,000 users in terms of providing this access to this dashboarding environment. And they also did not see any delays when it came to high concurrency spikes that typically occur during some market events. Another case study that we are seeing, and also it's just a use case that's becoming more popular, is boosting portfolio management performance to help mitigate risk, but also provide more advanced, smarter portfolio analysis. And this came with through the replacement of Oracle. And so their architecture included a number of ETL processes, so very traditional in nature, batch loading into a traditional data warehouse, which was Oracle Exadata. And then from there, they would do additional either prep of the data for their analyst community, or they would connect Tableau or an Excel sheet. And in some cases, they were doing SAS processing. Oracle was becoming the bottleneck. And it had a lot to do with the fact that they had to rely on a lot of ETL batch processes. Oracle really could not move to a streaming architecture and still provide all the access that they were requiring for their portfolio dashboards and analytic processes. So they were doing a nightly or hourly update process. A lot of this had to occur offline. So that meant folks didn't have access to the system. So off market hours, they were doing a lot of post-processing. And so if you're thinking about, again, that experience to customers that want continuous access to their portfolios with live data, they were unable to provide that because of the back-end processing that was occurring in the off-market hours. They also had a lot of aging models. So their models were not getting updated with the latest and greatest market data. And so they wanted to move to more of a continuous model development approach and using the most latest event data that was possible. And then also the query performance that they saw for their analysts and their portfolio managers was just becoming degrading over time. And the answer from Oracle was to spend a few more $1 million in upgrade costs in their hardware and distributing their data. And so certainly Oracle said that they could solve a lot of these problems, but it was going to come with a significant price tag. And so they moved to a new architecture where they ended up using Kafka as well. They got rid of the ETL-based processes and they moved to more of a real-time streaming ingestion model. They piped data into two essentially data stores. One was serving as a traditional data warehouse view for their analysts and their Tableau dashboards. And then they also provided a sandbox for their data science community and did a lot of sort of transformational work and ML logic with using Spark. So they introduced a Spark cluster that sat on top of the MemSQL environment as well as their Hadoop environment for other more longer-term analysis. And this gave them the ultimate benefits of great real-time ingestion. So they got rid of all of that ETL processing as well as the licensing costs that were part of that. They also introduced a classic Lambda architecture, which is moving your hot data, if you will, or the live feed of data into MemSQL and then piping the same data to your historical or archived data lake so that everything was in sync, so to speak. And so this provided all of their user communities the data access that they required. They also got to more continuous model development, so they were able to tune and train some of their models and also introduce new models using the more up-to-date data. And so this is something that they wanted to innovate and deliver to their customers, which is the ability to provide the latest and greatest trend data using whatever sort of new market trends, and ultimately they were looking to also mitigate against risk. So some of the advantages they did with this new architecture was providing more what-if analysis and pre-trade analysis using new updated models. They also got great performance in terms of their queries over Exadata. So because of MemSQL's in-memory and disk architecture, they were able to move some of those very fast or slow-performing queries to more of a memory-based architecture. They also got to analyze more data as well using MemSQL over Oracle. And ultimately, it came down to price as well. So this is something where, of course, Oracle has a lot of capabilities and bells and whistles, but it comes at always a price tag. And so this organization was just simply unable to afford the rising costs of their Oracle investment. So the key benefits for this application was around continuous, pre-trade analysis using the more fast-changing or live data that was occurring in the market. They reduced their Oracle spend, and they got to very fast performance. And so that's ultimately sort of the net of that application upgrade. The last scenario is fraud detection. And fraud is obviously a huge business. It spans a number of scenarios within banks, whether it's at the payment side, whether it's for insider trading. There's just a number of account creation steps. There's just a number of areas that fraud can be involved in. Just one example, the mobile fraud is a huge challenge for banks, just based on the rise and increase of devices. But they are accounting for 65% of most fraud transactions. And then in fraudulent deposits alone, they cost the industry $2.2 billion. So it's big money. RSA continues to put out reports that this continues to be a challenge for banks. I apologize for this grainy picture, but it is a reference architecture that we have seen customers deploy and use around managing fraud, and it has a lot to do with taking advantage of the open source based architectures, whether it's Hadoop and Spark, and of course there's Kafka in there as well. What we find is that when folks go down the path of trying to leverage a Hadoop-based approach for their fraud detection architecture, is that you run into a very complex performance environment. While you may be able to deliver performance under certain workloads, it's a constant, moving sort of target in terms of where the bottlenecks are. As you can imagine, the number of components that are required to deliver a high-performing, high-performance fraud detection application using largely Hadoop-based technologies can become very complex, but also it becomes a matter of trying to identify where the failure point is, because there's so many components and elements involved in the architecture. And then we do see customers struggling with the fact that a lot of the architecture does have SQL-like functionality, but in many cases it's not always the full SQL support that they're looking for. And so there's Java coding and other specialized coding required, and then you have to bring in experts. And then lastly, one of the big challenges that we see customers dealing with is the data silo effect. When you get into these distributed architectures of different technologies between Spark and HDFS and some of the Lucene or other sort of elastic-based technologies, is that you're sharding and splitting your data into multiple places. So that becomes not only just a complexity for management, but also a compliance issue. And so we see a more elegant architecture with MemSQL, where you can take advantage of Kafka, pulling in your multi-data source environment. You get that stream ingest into MemSQL, and then you can do your immediate millisecond response and spot check to an event and respond accordingly. But then also, because of MemSQL's column store engine, you can do other things like loyalty programs analysis and other inventive ways to work with that history of transactional data to provide value-added services. So this is where your fraud detection platform becomes a twofold service, where it's doing detecting risk, but also providing value to your customers. So it becomes faster in terms of just end-to-end performance. It's much easier to scale because it's just one system. You don't have all these multiple components to identify where the failure points are. It's completely familiar, standard relational SQL, and you can take advantage of our pipelines that does have extensibility built in. So this is where you can add ML functions on the stream as the data lands into the system, and it ultimately gives you just a more simplified environment. So to wrap up, I just went through a lot of scenarios and the application types that we're seeing customers use MemSQL for. I just want to highlight the fact that MemSQL is a great fit for a lot of different types of financial service applications. It has a lot to do with our relational SQL interface, the fact that we believe in ANSI SQL, the fact that we have full ACID transactional support, but also data warehousing in a single system. The lock-free ingestion, working intimately with the Kafka environment, is a very popular architecture. The fact that and I didn't point out some of the uniqueness of what gives us the great query performance, but it has a lot to do with our ability to compile queries for operational speed. It's completely, massively parallel processing. We are usually, in most cases, going to be very fast, much faster and cheaper than your traditional systems, whether it's Oracle or Sybase or some other sort of Netezza-based system. Of course, we are built for operational requirements, so that includes security and availability. I do recommend that if you want to learn more about the product, that you can either try it out yourself, or you can email us at team@memsql.com and we can get you set up with a demo for your application. We can answer questions for you, but we can also help highlight maybe some use cases that you didn't see today. We do have a free version of our product. It does have the full capabilities, and you can use it in production. There is only a limit, is the amount of memory that you use with the environment, but it does not have any limitations on how much disk you put on MemSQL. So that's a great offer there. And with that, I'm going to hand it over to Alicia, and we'll answer a few questions.
Thanks for your presentation, Mike. As a reminder, you may submit questions through the Q&A function located in the lower right side of your console, or tweet us using hashtag #MemSQLwebinar. So it looks like some questions have come in. Let's start with this one. How does MemSQL work with Spark, and what use cases does it support?
Yeah, so Spark is certainly great at doing, acceleration for your Hadoop architectures. But in terms of how it works with MemSQL, we see folks use it in two ways. One is we use it for the transforming of data on the stream. So they use Spark streaming. And then we see folks using, the ML library to do some sort of ML function on the stream of the data before it lands and is sort of inserted into MemSQL. So we see it as a processing layer that occurs before hitting MemSQL. We don't necessarily see folks use it for, an in-memory engine like it is used commonly with Hadoop. So in many cases, we see mostly a Kafka stream ingest into MemSQL, whereas Spark tends to be a little bit more on the transformation layer. Again, commonly used for more of the ML logic, since MemSQL has some ML functions built in, but certainly Spark has a lot more, and so you can take advantage of that capability.
Thanks, Mike. What types of geospatial data do you support? Raster, vector, what type of querying of geospatial data do you provide?
Yeah, that's a good question. And so the first point I will make is that our full geospatial capabilities can be found in our docs page. So you go to docs.memsql.com, and you'll see, at the very top level on the left navigation, our geospatial support. I don't think it's raster based. I believe it's vector based, but I don't want to speak out of turn on it. So I would recommend going to our documentation. We do have a number of customers that use our geospatial capabilities. Some of them are in the public sector. I know Uber is a very big proponent and user of our geospatial capabilities, and they're fairly sophisticated. But I don't want to also misrepresent our level of support that, in terms of the specifics of the question. So I recommend going to the docs page.
What is the MEMSQL license model?
Yeah, so MEMSQL is licensed based on well, first of all, we, as I pointed out earlier, we do have a free tier version of our product, and that is licensed. Well, it's not licensed, but it can be used based on the number of amount of memory that you have allocated to the system. But in terms of subscriptions with customers, it's a combination of, it's usually a node-based approach. So it's the number of nodes that you have deployed in your architecture, and then we'll work with you on determining, based on that node configuration, what the pricing will be. Some customers have used us with memory-based licensing, but that is a model that we do not sort of necessarily carry forward for our new customers. So think of us as a node-based licensing environment.
Thanks, Mike. Does MEMSQL integrate well with Apache Flink? Do you have any use case where a customer is using MEMSQL with Apache Flink?
Yeah, no, I know that there was a customer that was using Flink in their architecture with Elastic and HDFS, and we replaced that with Kafka and just MEMSQL. And so I don't know if we've done any explicit testing or if we have customers using Apache Flink so I don't want to also misrepresent that integration. I guess fundamentally, we are a JDBC and ODBC compliant interface. And so a lot of customers tend to work with us under that premise. We also support the MySQL wire protocol. So that means a lot of technologies that work with MySQL will tend to work out of the box with MEMSQL. So I think that's a general sort of it should work comment, but if you really want to get into more production-oriented analysis and workloads, you should contact our sales team, and we can work through that integration to make sure it's safe and sound.
Can MEMSQL work as a standalone data warehouse like a Netezza, and how does it differ from the dedicated data warehouses?
Yeah, so MEMSQL is, it's one of those unique technologies where it offers data warehouse characteristics and capabilities. It can absolutely serve as a dedicated data warehouse, and we do have customers using us for that. Where we're unique is that we provide this ingest engine that's largely row store based and memory based, and that's the capability that most data warehouses just don't have. So you've got this sort of traditional classic data warehouse engine, and we're really excited to be looking to provide some benchmark data to showcase just how fast we are as a data warehouse. We can compete with just about anybody in the market on a data warehousing workload, but we're not just we don't just provide that workload. We also have other operational workloads that we do great at, and so that's what makes us unique.
Is Kafka mandatory for using MEMSQL?
No, it's certainly not. I mean, we certainly have customers directly ingesting data from their application straight into MEMSQL. We have ETL products that are used to drive data into MEMSQL. So no, I think the short answer is it's a popular mechanism to queue your data, especially when it's a multi-source queuing model or message architecture that you've got. It works great because we've got a built-in pipeline capability that works out of the box with Kafka. But no, the short answer is it's not required, and not all of our customers use Kafka with MEMSQL.
it looks like we have time for one last question. What are some of the larger deployments of MemSQL in terms of data managed and number of users?
Okay, that's always the common one. So yes, from a sort of just general size of data managed in MemSQL, some of our larger deployments we're approaching the petabyte scale. I think Pandora's got a pretty interesting blog post that they wrote where they were scanning, I think it was 300, getting into a 400 million row table using MemSQL. So we're in the hundreds of terabytes at production scale, and then in terms of let's see, another high water mark, if you will, for ingest, we have customers that are at the millions of events per second in terms of ingestion. So that can get you into the telco oriented workloads. So certainly very easy for financial services. We wouldn't have any problems managing ingestion demands for a financial service use case. And then lastly, concurrency. We see, I think I shared a 40,000 user application. I think we have other applications that are similar in scale to that. In terms of like real high load user concurrency, thousands of users hitting the system simultaneously is something we can easily handle. But technically there's no limit because we don't have any sort of physical or constraints around how many nodes you can deploy on MemSQL, and so therefore technically there's no limits across ingestion, users, or amount of data managed.
Thanks, Mike. So that's all the time we have for today. Thank you, everyone, for all of the questions. I want to thank Mike and each of you for attending today. Just a reminder, we will be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, you can send an email to team@memsql.com. We invite you to learn more about MemSQL at memsql.com or give us a try for free at memsql.com/product. Again, thank you for participating and have a great remainder of the day.